What is it?
I want my Ryzen 7 processor on my laptop.
I'm dropping like 800 bucks.
Okay, good morning.
Good morning.
It's ECET101, right?
Yes.
How many do we have here? We're supposed to have 27.
At least 20.
At least 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only 14?
Yeah.
Okay, this is the first class. So means the original classroom is in the business building. So we just changed it here. So I'm not quite sure. Maybe somebody has gone to that classroom. So that's the first time. That's okay, right? My name is Joe. My office is in Tech Building 318C. And this class has a lab, right? And the lab is 319. So just cross the hobby. We are going to do the lab next week. And then we don't have labs this week.
Does it
Yes.
start on September 10th? The labs?
The labs start at 11:30, right? 11:30 to 2:45. And everybody need to enroll in the lab. Right? You need to only enroll in one section. So either Tuesday, Monday, or Wednesday, right?
I think I have it Monday.
You get Monday or Wednesday, so you choose only one day. Okay. We have another section, is the third section, the time is TBA. But you need to do the labs either on Monday or Wednesday. The TBA section is, the reason is because sometimes you have a time conflict. So this is more flexible for you to enroll in classes, but you still need to do the labs within these 2 times. The scheduled time is like more than 3 hours, but I don't think you need that long to finish the lab. So if you need to leave earlier for some other classes, that is fine. Only finish your experiment. At that time, we are going to have a teaching assistant help you to do the labs. We have about 8 labs. The first one is just brief introduction, give you some like safety tips, and then you are going to have 7 experiments for this. And the details will be discussed in the lab. We have a website. The address is this is my website. You go to the website, on the left-hand side, you click teaching, and you are going to see a list of courses I'm teaching. And the courses I'm teaching this semester, you can click. One is ECET101. You click it, and it will ask you a password. The password is electronics. Then you go to the class website. The syllabus is on the website, and the lecture notes also on the website. The homework announcement and the other information about midterm or finals, right, will be on the website, so you can see. This class is 2 credit hours. The additional lab, the separate lab, is 1 hour. So totally you have 3 hours. You must enroll at the same time. This is the co-requisite. Today we are going to discuss briefly the syllabus, which you can download from my website. Then we are going to discuss the first chapter. This class is the first major course in electronics. So I believe all of you are from EET and CET. Anyone else? Anyone from other majors? I know some maybe from CET. Okay, CET and EET. Yes.
I couldn't really tell the
You cannot read this, right? This one is also okay. The website is http and orca.st.usm.edu. And slash is tilde and ZHOU. And the syllabus is on the website, the lecture notes, the homework. We have textbook. This is the textbook. Anyone get the textbook yet? I believe it's in the bookstore. It's already in the bookstore, right? So this is a very good book, right? So you need to get the textbook. The homeworks will be in the textbook. And also you need to read the text. Today we first briefly discuss the major topics that will be discussed in this class. Right? The first one, we are going to discuss quantities and unit and measurement. The quantities deal with numbers. A unit, we are electronics, so we deal with the voltage, currents, and the resistance, capacitance, all these things. So we need to know the appropriate unit, and they have different units, big unit, small unit, and we need to know the conversion between each one. The second topic is the basic voltage, current, and resistance. We are going to discuss what it is, what current is. You may already have some ideas about this, right, in high school. And we are going to discuss the basic laws between voltage and current, which Ohm's law. Right? And we need to know how to calculate the power. The electronics sources provide power, so we need to know how to calculate the powers. And the energy, the power and the energy are related. The next topic will be related to circuit. Right? The simplest circuit is a series circuit and very simple parallel circuit. So we are going to discuss series circuit, parallel circuit, the properties, the connections. And also in the labs, you are going to discuss how to connect, how to take the measurement of a series circuit and parallel circuit. We are going to discuss the relationship between, for example, voltage, current, and the powers. And you are going to verify in the lab all this relationship. The next topic will be magnetism and electromagnetism. We are going to give you a brief introduction in this class, because later time you are going to take Physics 201, Physics 202. Physics 202 will give you more study in magnetism and electromagnetism. Right? So in this class, it's only an introduction. The next one, we'll discuss a little bit alternating current and voltage. That's the AC voltage and the AC current. The first part is Ohm's law, or something we discuss. We use DC circuit, direct current, direct voltage as example. Direct current means the current only flows in one direction. AC current means the current flows back and forth, oscillating. Then in DC circuit we discuss the resistors, and we are going to discuss components used in AC circuit, which are capacitors and inductors. We discussed briefly the connection, how to calculate, for example, the total capacitance of a parallel and series circuit. The next topic will be transformers. So everybody knows transformers, right? Okay, the power supplied to your community at the beginning, the voltage is very, very high, right? More than 1,000 volts or kilovolts here. Okay, then into your community must decrease the voltage to like 110. So that is the voltage we use in our home. And also the current can be changed with the transformer. So we are going to discuss basic properties of transformers and the types of transformers that will be used in daily life. If time permits, we are going to discuss some other nonlinear device, as for example diode, which is very typical in labs also. That's pretty much what we are going to discuss in this class. If you have any other interest, you think is you have interest and you think is important in this class, you can bring to me. If time permits, then we can discuss it. So any questions about the topics? The next part is the course objective. So I listed in the syllabus, you can read. That is the objective, and the outcome means after the class, what you should be able to do. So also that's the skills. It's also listed on the website. The next topic is homework. That is important. We discuss lectures here, and you read the textbook, then you need to do the homework to verify that you understand everything. We are going to have weekly homework. And the total number of homework set is about 8 to 10. So basically, after each chapter, you are going to have at least one set of homework. You are going to be given at least 1 week before the due date. For example, I give you the homework today, it's most probably it's due today next week, even longer time. So you read textbook, understand the lecture notes, then try to do the homework. I suggest you do the homework as early as possible. So after we finish one topic, then you do one by one. Do not wait until the last minute. Based on experience, if you wait until the last minute, you don't have enough time to finish that. And that is not a good experience. So I suggest you do the homework as early as possible. No later homework submissions will be accepted. So submit at the beginning of the class. You just submit hard copy here. If you have some, you need to skip the class, then you can submit by email. I would like to have a PDF file submission, so you can email me. The next topic is examinations. That is also important. I need to give you a grade, right? So we are going to have 3 examinations: 2 midterms, 1 final. All these examinations will be closed book, right? But you are allowed to bring 1 piece of letter-sized paper. You can write anything you want on both sides, but you need to write by yourself. You cannot print. The total grade, the breakdown of the final grade will be the attendance is 10%, and the homework is 20%. And the midterm, each one is 20%, so we have 40% for both. And the final exam is 30%. So totally you have 100%. If you get 90 and above, you get A, and 80 and above, that is B, and so on. If you get below 60, don't do that, right? So if you below 60, then you need to come back next semester. So any questions on this one? The grade for the labs will be evaluated by the TA, and you have a lab report, and all the requirements will be discussed in the first meeting in the lab. Another policy is collaborations. In this class, I strongly encourage collaborations between your classmates. That means if you have anything you don't understand, no matter in the textbook, the lecture notes, the homework, you can discuss with your friend, with your classmates, with me. But when you submit your homework, you need to write by yourself. You cannot just copy from others. Before you write, you need to understand. The reason is very simple. It's against the rule if you copy, and also in the test you cannot collaborate. So you need to do by yourself. So that. If you want to perform well in the class, you need to come to the class regularly. Right? My requirement, you need to attend the class every time. So that contributes to your final grade. The reason is you can see we are going to discuss a lot of things in the class. So if you skip one, always 90 minutes, but if you want to read by yourself, study by yourself, you need much more than 90 minutes. So that's not efficient. So I suggest you come to class every time and review after the class. And even better, if you can preview the textbook and the lecture notes, it will be even better. The university has a lot of supporting services. For example, if you need support for writing, although not quite, this is the first class. Writing or speaking, we have a speaking and writing center. You can check, especially later time when you do the senior project. If you need to write something, if you want to do the presentation, then you can go to the speaking center and the writing center seeking for help. We have extra resources. If you need help with math, I believe math department has a tutoring center. It's called Math Zone. So I believe you can seek for help there. And the School of Computing also has a tutoring center. Some graduate students will sit there. If you need help, no matter math or circuit. I'm not considering the circuit because we do not have many graduate students in math, in electronics. Maybe in computer science. So if you have a coding class, you need help, then you can go to them. But anyway, you can always come to me for help. My office, the office hour, on my website, there's a column is called a calendar. So you can look at that. My office hour will be posted there. Or anytime if you see my door is open, then if you can find me, then we can discuss. Electronics, even later time if you have any other problems, we can also discuss. I know some students discuss with me like some physics questions, math questions. That's fine with me. Okay. Absence, as we said, you need to attend the class every time. But if you have some emergency, medical emergency, family emergency, okay, you need to have an excuse. If you cannot maintain 80% of attendance, 80%, for example, 20 times, if you missed 3 or 4 times, then you are required to drop the class because it's not easy for you to catch up. So keep in mind, do not skip more than 4 times. If you have a planned emergency or something, not emergency, okay. If you have a plan, need to skip a class, let me know as early as possible. We may arrange some help. Okay? But coming to the class late or something, that is not an excuse. Incomplete withdrawals and drops. I do not give you incomplete grade. Incomplete means in the halfway or somewhere you cannot finish the class. Okay, so you want to stay here, you want to come back next semester. Right? So I give you an I, then you continue next semester. You finish the work, then you get no matter what you get. But this one only for very rare situations. So far, I don't think I have given any incomplete. So keep this in mind. Withdrawals and drops. So you need to check the website, university website, to find the deadlines. If you need to drop, you need to quit. Do this before the deadline. You can get your money back, or you can do not let the bad grade show on your transcript. Academic integrity. So everybody are familiar with this, right? So as for example, you cannot copy, you cannot cheat. Right? If you need to write something submit to me, that must be your writing. And we have several points listed in here. You can read by yourself. This is very straightforward. It's easy to understand. Professionalism. We also have something you need to respect your classmates, respect be polite to each other. Right? So all these things are listed on the syllabus. Communication devices. So everybody has a phone, right? Okay, but we do not need a phone in this class. So if you need to bring the phone with you, okay, please turn it off. Right? I do not want to hear any noise in the class. If you have some emergency, for example, no matter what, if you want to make a call, please go outside and for the rest of the class, so don't make a call, don't make any noise in the class, because this is not good to others. Computing device, computers. We do not need computers. So basically, I suggest you do not bring computers to the class, especially you do not send emails, okay? Go to social media or do anything else. So everything is on the textbook and the lecture notes here. So you can write the lecture notes, but do not bring computers. So if you have a special need, if you have a special need, you let me know, that's fine. We are flexible. What else? Okay, ADA statement. If you need a special, if you need the ADA service, you let the office know, and they will contact me directly, so we can make an arrangement. So that is okay. And in the syllabus, we have a list, tentative calendar listed. So for example, the first unit is quantities and unit, and the corresponding reading in the textbook is section 1 to section 5. So you can use this one as a study guide to do this. Because this is only 2 credit hours, and we will have only like 15 classmates. So 15 classmates plus 2 midterms plus 1 final, that is totally 18 times. So we may stop at the mid of the semester, right? So because it's 2 hours. Okay, any questions before we discuss chapter 1? You can ask any questions. Any questions? No? Everything's good? Do you have an eye clicker with you? Who has an eye clicker? The voting device. Anyone has that? No? Because at the end of the chapter, we are going to have some review problems. So if you have eye clicker, the physical device, or you can, I think there are a lot of apps.
Yeah, I have the
You have apps, right? So on the phone, right? So, but anyway, we can do the first time we don't need, we can try, right? Right, the first chapter is the unit and measurement. This one is only a summary, so you can see this is the summary. So we cannot discuss everything in the textbook here. Right? So that's why you need to read the textbook completely. We only discuss the most important things. That means maybe more difficult to understand. So we discuss here. Everything in the textbook can be in the homework, can be in the test, right? Not only in this lecture. Right? In electronics, engineering or technology, we need to deal with numbers. For example, the resistance or the voltage. As we said, the voltage can be very high. So like million volts. So we deal with the big numbers and the small numbers. So in this example here, like 47 million, this number. So we need to use the scientific and engineering notations. So you already know the scientific notation, right? Scientific notation, for example, 47 million. How to write this one in scientific notation? The scientific notation is represented by, first one there's a number here, at the very beginning. Then times 10 to the power of 10. And the requirement is this number here must be greater or equal to 1 and less than 10. So must be, at least must be 1.0. At maybe 3.5. At most is 9.99 something, cannot be equal to 10. Right? So that's the requirement. Then with the power of 10. Right? For example, here you are going to have 47, so it's 4.7. Then you count how many zeros, how many digits between this dot and the end of the number. So in this case, the dot 4.7 is 1, 2, 3, 4, 5, 6, 7. So that's 10 to the power of 7. Okay, is this clear? Sometimes we need to use engineering notation. Okay, this one is the engineering notation. So anyone knows the engineering notation? Engineering notation is a special types of scientific notation. Right? The requirement is the power can only be multiples of 3. We cannot have 7 because 7 is not multiple of 3. So we can have 0. 0 is multiple of 3. We can have 3. We can have 6. We can have 9. We can have a -3, -6, -9. Anyway, so positive or negative multiples of 3 and 0. 0 is also, right? So in this case, we have like what we do is you just count from the end to the left. So 1, 2, 3, 1, 2, 3. So that is 6. Right? If you count more, you can count more, right? So in this case, if I count only 6, so that we have 47 left. So 47 times 10 to the 6. So that is one type of engineering notation. Right? We can have more types. For example, if I want to use 10 to the 3, so this number will be 47000 times 10 to the 3. That is also correct. It's also an engineering notation. Right? And we can use this 9. So if I use this 9, what this number is? 0.047. Yeah, perfect. Right? So scientific notation is unique. We can the correct one is the only one. But the engineering notation, we can have a lot, infinite. Any questions on this? Okay, so this one is another example. This one is a very small number, 0.000027. And we use a scientific notation. It will be, what we do is you move the dot to the right. So 1, 2, 3, 4, 5 times. So you get 2.7. 2.7 is between 1 and 10, so that is good. So 2.7, because we move the dot to the right by 5 times, so the power to 10 will be a -5. Instead of positive 7 in the last example, this one is -5. So if you move the dot to the right, you need to use the negative power. To the left, that will be positive. And for engineering notation, we can use -6. Then you move another one to the right. To the right. So the number will be 27. So 27 times 10 to the -6. So again, engineering notation here is only one of the a lot. Okay, this example here, 0.605. The scientific notation is 6.05 times 10 to the negative 1. And the engineering notation will be 605 times 10 to the negative 3. Again, this is one of them. A lot. Okay? Let me ask you another. The number is 5. Right? What is the scientific notation? The number is 5. What is the scientific notation?
5 times 10 to the negative
5 times 10 to the negative 3. Let me write. The number is 5. That one equals what? Just 5 times 10 to the, we need to have 10 to the,
To the first. To the 0.
10 to the first. 5 times 10 to the 3, 1,
0.
0. Any other options? Oh, no? Okay. 0 is correct, right?
Right.
Because 10 to the 0 equals 1. So any number to the 0 equals 1 except 0. 0 to the 0, that's not defined. So all others number to the 0 equals 1. So 5 equals 5 times 1. And 1 equals 10 to the 0. Right? So that is the scientific notation. Right? 10 to the 0. Does this make sense? Good? In the homework, the first homework, you may want to try this. So, all right, you have calculators, and sometimes we have some special case. You can convert a number into an engineering notation and scientific notation. So, very easy. Different calculators have different cases. So if you use your calculator, you need to, if you want to use this function, you need to get from your class. Okay, next one is the standard unit for quantities. The first one is the length. If we want to measure length, the standard unit is a yard. No, okay. Standard international standard unit is a meter, right? How long is 1 meter? Is that show me?
1,000 millimeters.
Yeah, 100 centimeters, right? How long? Can you show me? This long? Oh, yeah.
That's long.
Like 1 yard, a little bit more than 1 yard. Right? So I know not word. Anyway, it's meters, and the symbol is M. What is the unit for mass?
Kilograms.
Kilograms. So represented by kg. What's time? Time is the second. And F. What is electric current?
Per ampere.
Hey, how do you know this? We haven't discussed yet.
It's for ampere.
Okay. So this is ampere, and the symbol is A. Okay. How large is 1A? Oh, we are going to discuss later. Right? Temperature. The unit is Kelvin. The unit is K. The symbol is K. Others we do not use this, so we just use it here.
Any
We are more interested in electrical unit, right? And except for current, all electrical and magnetic units are derived from the fundamental unit. The current is the fundamental unit. What is the unit? What's the unit?
Amperes.
Amperes. Okay, the symbol is A. Okay. Current, and we need also electric charge, and voltage, and resistance, and power. This one is A, the electric charge. What is the unit for electric charge? Coulombs. It's C, right? What is the unit for voltage?
V.
V. Resistance.
Ohms.
Ohms. Good. Electric power.
Watts.
Joules. Watts. Joules. What is for joules? What unit is joule? The watt is for power. What is for joules?
Something per second.
Energy, right?
Yeah.
So the energy. What's the difference between power and energy? You pay your bill each month, right? So you pay for your power or you pay for the energy?
The energy.
You pay for your energy, right? No? Yes or no? Yes, right? So we pay for the energy, not for the power. The power can be very large, but the energy still can be very small. We are going to discuss the details, how to calculate all this later time. Right? So this is just the basic unit. All these units except A are derived from the A. That's called the MKS unit. Engineering metric prefix. What is K? Kilo means 1,000, right?
Yeah.
1,000 ohm equals 1 kilo ohm. What is M?
Mega.
Meg. This is small letter. This one is capital letter.
Yes.
Can we write a small letter?
Then you'll be millized.
Yeah, right. Okay, small letter means -3. This one means sorry. Meg. What is small m? This one equals 10 to the 3, right? 1,000.
Yeah.
This one equals 10 to the 6,
Yeah.
means 1 million. What is the small m? Say the million, right?
Yeah.
10 to the
negative
3, right? Not -6. And G, gig, 10 to the 9, right? Gigahertz. What's your frequency of your cell phone? Anyone knows? You make calls every day. You use your cell phones every hour, right? What's the operating frequency?
60 hertz.
60 hertz.
I don't know.
Your cell phone means, for example, you receive or transmitting signals from your phone to the tower.
Yeah, it is eager.
Gigahertz. Okay, around gigahertz, at least the megahertz. So maybe 900 meg or several gig. Right? So that is it's very high frequency. 60 hertz is the power that is the frequency for this power.
60 hertz.
Okay, 60 hertz, right? And T, what is T?
Tera.
Tera is 10 to the 12, right? Like, and P is 10 to the 15, right? Okay, good. So his name is kilo, mega, gig, tera, and keta. And this 10 to the 3, 6, 9, 12, and 15. All these are engineering notation, right? Right now we have a small unit. And the first one is, okay, we go from the top, right? So from big go to small. Milli is 10 to the -3. And what's the next one? What do we call that? Micro. Micro means 10 to the -6. What's the next one?
Nano.
Nano, 10 to the -9. And next one? Pico, right? 10 to the -12. And F is I don't know how to call this, but anyway, it's negative 15, right?
I don't know that one.
And which one are you familiar with?
All of them, except for F.
All of them except F, right?
I don't know F.
Nano material, right? Nanosecond. And micro.
Microsoft.
Microsoft. Did you say Microsoft? Spell it out, it's Microsoft. You're right.
Okay, anyway, so maybe we are more familiar with the nano, right? Nano material, nanosecond,
Like a micro-
nanometers, all this, right? Okay. We need to be familiar with all these units, and we need to convert from one to another. Okay, the last one is called femto. 10 to the negative 15 femto. Okay, we discuss all these big units, small unit. Next one we need to know how to convert one to another. Right? So this one, 0.47 mega ohm. That is the resistance.
That's a lot of resistance.
Okay, that's a lot of resistance. Right? Equals I want to convert into kilo ohm.
Right.
So this one equals negative. This one is positive 6 to the power of positive 6. This one is positive 3. So the unit of M is 1,000 times larger than this one.
Right.
Because the unit is large, so the number, the value will be small, right?
Right.
And this unit is small, so the number must be large to keep this equivalent. So 1,000 times, so that means you need to move this one to the right, make it 1,000 times larger. So 470, 470.
Right.
That's easy, right?
Yeah.
Okay. But based on my experience, right, in the homework, you can still get missed. Right? Just be careful. It's not that difficult, but you need to be careful. Right? Move the dot to the right or to the left. That is the question, right? So keep in mind, if you want to change the big unit to small unit, the number will increase. Change the unit from big to small, the number will increase. Large number for small unit. Okay, next one. 10,000 pico. What is F?
Farads.
Farad. Alright, that is the unit for capacitance. We are going to discuss later. Anyway, this is the electronic unit. So 10,000 pico equals, we want to convert into a microfarad. This one equals negative 12. This one is negative 6. So this one is 1 million times larger than this one. So we need to make this number 1 million times smaller. That means we need to move this dot to the left 6 times. So here, 1, 2, 3, 4, 5, 6. So we have 0.01. Question on that? You can try from the right hand side to the left hand side. So smaller number and the big unit. This unit is small, but compared to the P, still large. Okay, next one, we are going to, sometimes we need to add several quantities, numbers with unit. For example, 10,000 ohms plus 22 kilo ohms. How to calculate this one? We need to, step one, we need to convert all the unit to the same unit. That means we can convert the ohm to kilo ohm, or we can convert the kilo ohm to ohm. Doesn't matter. If you have requirement, then you do as required. Otherwise, you choose no matter which one you like. So in this case, in this here, the first one is convert the big unit kilo ohms into a small ohm. So 22K is 22 shift to the right by 3 times. Okay, 000 ohms. Now 10,000 plus 22,000 ohms, that will be equals 32,000 ohms. So that is the first. Or, because we don't like this big number, right? So we want to use smaller numbers. So we are going to convert this big number into a smaller number with a big unit. So 10,000 ohms equals 10 kilo ohm. And then plus 22 kilo ohm. So kilo ohm here, they are the same. So 10 plus 22 equals 32. Okay. Okay, now this one. 200 microamperes plus 1.0 milliamperes equals the first one, we convert this 1 milli into micro.
Right.
Milli is 1,000 times larger than micro, right? So 1 will change into 1,000. Right? So 1,000 plus 200, that is 1,200 micro, a small unit. Or if we go this way, right, we convert micro into this. What is it?
22.
This one will be equal to what is this in unit of milli? 0.2 milli MA plus 1. That will be equal to 1.2 milliamperes, right? Or once you get this one, you can just shift this one to the left by 3 times and convert this micro into milli. Right? We already did this. In electrical engineering, we are going to take a lot of measurements. So in the lab, so you also need to measure the voltage, the current, the resistance, everything. So if you take a measurement, you are going to have error. You cannot measure exactly. So we have errors. We have another concept is called accuracy and precision. What is the error? The error is the data you measure, the difference between the data you get with the correct one or the exact one, although sometimes we don't know. So experiment uncertainty is a product for all measurement. Error is the difference between the true and the best accepted and the true. Sometimes we don't know the truth. Accuracy is the indication of the range of the error in the measurement. Now we see the difference between the precision and the accuracy. Suppose the target is in the center, it's yellow, and if you shoot at this point, that distance is the error. And if you shoot multiple times, this one here, so we call your shooting is precise. You shoot at this point almost all of them. At this point, it's precise, but not accurate because the target is here. So this example is precise but not accurate. Can you give me an example that is accurate but not precise?
Spread around the target.
Okay, you spread around the target. For example, one is here. That's very good, right? Precise and accurate. Another is here, 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 here. Looks like it is around this center, so it's accurate, but it's not focused on this point only. Spread, scattered. So that is not precise. So you can see what we want is precise and accurate. What we don't want is not precise and not accurate. Any questions about this? Yes.
What makes that error mean?
This error is okay. We know the correct data is here, but the data you get is here. So the difference between these two is called the error. For example, I give you a resistor. Right? I tell you the correct resistance is 1K, but when you measure it, it said, okay, 1.1K. Then that difference is 0.1. That is called the error. Okay? Does this make sense? So, for example, the correct one is the truth is 1K with like 1,000. And your data, your measured is first time this one, next time is like this, next time is like this, and then like this. You give me 4 measurement. So how do you comment your measurement?
I'd say precise and pretty accurate.
It's pretty precise, right?
Not too accurate. Well, not too accurate.
But not accurate, right? Because the accuracy is only 1,000, but you have like 10% off. So this is precise, right? Everything is very, only 99, 100, okay, 101 is very precise, but not accurate. So this is one. Another one is, for example, said 999, 998, for example, 1002, 15 or 995. This set of data. So you can see all these are closer than this to the true value, 1,000. But you can see the difference. This is 5, the error is 5, right? This error is this is -5. This error is -2. This error is -5, -2. This is 2. This is 5. So the error is that is accurate but not precise. This the error here is 101, 100, okay, 99, 99. So the error also large, but this set is precise. So you see the difference, right? Okay. Any further questions on this? Next topic is a significant digit. Again, I think you know this, right? Significant digit. When we report a measured value, for example, I said my measured resistance is 1, 2, 3, 4, 5, 6, 7, 8, 9 kilovolts. What does that mean? There are several things. The first one is I just made these numbers. Okay, I cannot measure this accurate. The second one, if I can, that means my equipment is very, very precise. It can measure up to this one. But usually it's not necessary. Right? In general, we do not need so many digits. We need only like 1 or 2 or 3 or 4. Usually that is called a significant digit. Significant digit. Normally, this is the same number of digits as in the original measurement. Okay. Here, assume two measured quantities are 10.54 and 3.92. If the larger is divided by the smaller, the answer is. You have calculator? Can you calculate this? The larger number divided by the smaller number.
About 270.
Okay, I know there must be a lot of numbers, right? A lot of digits. Okay, the answer is you need to take 2.69. Okay? The reason is because the answer has the same uncertainty as the original measurement. You do not need to give me this result is 2.69. You don't need to give me like more than this 2.69, 1, 2, 3, 4 along that. That's useless, meaningless. So what we need is only 3 significant digits, because in the original data it's only 3 significant digits. Does it make sense? So next time when you go to the lab, you measure the data. So when you calculate the result, you do not just give me, okay, I think very accurate, 2.69345, okay? All those are useless. You take the significant digit as long as this one. How about this one? Can I take 4?
No.
No, you take the
Small.
the smaller one, right? Rules, how to determine a significant digit. The first one, non-zero digits are always considered to be significant. Second, zeros to the left of the first non-zero digit are never significant. I think we have two examples. Okay, this one. Non-zero digits are always considered to be significant. So 23.92, we have 4 significant digits. And the 0 to the left of the first non-zero digit are never significant. So 0.00276, we have only 3 significant digits. Only 2, 7, and 6. All the zeros before that don't count. Number 3, zeros between non-zero digits are always significant. For example, if you get a quantity of 806, right? You count 8, you count 6, and you need to count 0 also. So this is, there are 3 significant digits here. 4, zeros to the right of the decimal point or decimal number are significant. Right? Look at this one, 9.00. How many significant digits do we have here? 3. Right? Those 2 zeros have meanings here, right? Not randomly put zeros. So that means it's accurate. The last 0 is also accurate. So when you calculate the number, don't put some zeros randomly at the back. Right? That means different things. 5, zeros to the left of the decimal point with the whole number may or may not be significant depending on the measurement. For example, this one, 4,000 does not have a clear number of significant digits. But this is an integer, decimal. So 4,000, maybe we have 4 digits. So that means this 0 is accurate. Or maybe I just counted like 1,000, so just 4,000. And the next one maybe 3,000 or 5,000. So all these are not accurate. So the significant digit can be 4, can be 1. Rounding numbers. That's elementary, right? Rounding is the process of discarding meaningless digits. Rules for rounding are: if the digit dropped is greater than 5, then increase the last by 1. If the digit dropped is less than 5, do not change the last retaining digit. If it is 5, then we have a different treatment. You can just drop, you can just add, but we use round to even rules in here. A round to even. Okay, now I have examples to show this. For example, 1.25. I want to round to here. This one equals 1.2 or equals 1.3. 1.2. Right? We are going to round to even because this number here is already even, so we round to 1.2. So this is correct. 1.35. What is this? This is 1.4. Right? So because 3 is odd, so we need to round up. Okay, next one discuss some fundamentals, right? Utility voltage and GFIC. And that is the outlet here. You can see from on the wall here. That is exactly what we have here. And if you observe carefully, you can see this one is larger than this one, right? They have a different size.
Yeah.
And this one, what do we call this one? This is ground. What does that mean, ground? Is that ground this ground? No?
Wait.
Yes? You don't think so? Why is it called ground? Right, so where does this ground connect to? Yeah, the actual ground. It is connected to the ground. Right? What you have here is there's a rod or something, a wire. It's connected directly to the ground. Right? And all through the building. And every this terminal is connected to that. So it is connected to the ground.
Yes.
So it is connected to my foot, right?
I hope not.
What? Why not?
I don't think you want to. I wouldn't want that to go through you. I'd rather go to the
There's
ground.
no ground, especially.
No, I'm on the ground.
I mean, so go through you if there's no ground wire.
Yes or no?
Yes.
So I said this point is connected to my foot,
Yes.
to your foot, right? Yes. So this one is connected to your foot. The reason is if we touch something, so this one is ground, so it has no electricity. Okay, so this is ground. And usually, when you do this in engineering, so you need to connect this one to the metal, for example, the pipe or the metal bars or anything. So it's directly connected to the ground. So make humans, make equipment safe. So that is the ground. And which one is hot? Hmm?
The bigger one.
The big one? Okay.
I never noticed it.
So the neutral is this is the neutral. The small one is hot. Small and hot, that's the reason, right? It's not easy to put something in. Okay? For little kids, it's not easy, right? The big one is easier than the small one. So the small one is hot, right? This is neutral. And this is ground. Okay, GFIC. How this works? It measures the difference between the hot. If you accidentally short this circuit, it will trip. So safety, it's for safety. Okay, next one is electrical safety. That's very important. You go to the labs. We do not want you, and you do not want you to get hurt. So that's the first thing. The first experiment we are going to discuss a lot of safety tips, measures. Okay, so you need to follow the rules. For example, when you do the labs, usually you do not do the labs by yourself. Especially in high level, seniors, juniors, do the electric power labs. You need to at least have another one with you. You cannot do the labs by yourself. There are some rules. For example, you do not want to operate with your two hands. When you do music connections, for example, you do not want to use your two hands to do this. Why? You have a closed loop, right? This is hot, this is neutral, then the current will flow, then you can try. So usually you just use one. We are going to discuss more details later time on this. Do not work alone. When you are sleeping, do not wear conductive jewelry. For example, if you have a necklace, gold, silver, the better the worse. Right? Gold is more conductive than silver. Right? Silver is more conductive than copper. Copper is more conductive than iron. So the better the worse, right? So you do not want to do that. When you make connections, your necklace may touch the hot wire. Give you trouble. Know the potential hazard of equipment you are working on. Check equipment and power cord frequently. Sometimes the cord here can broken. So if you touch this one, sometimes you get electricity. Avoid all contact with energized circuit, even low voltage circuit. In our lab, if you use the voltage source, something that is like DC voltage, at most like a 30 volt, so it won't hurt. But do not think, even it's low voltage, you always think it is high. For example, for typical AC, that is, how high is this? 110, right? 120 can kill you. And if you take EET for 61 liter time, that voltage can as high as 380, even higher. Right? There are three-phase voltage. So follow the rules. Right? Don't die. We want to see you at the end of the semester. Right? Maintain a clean work space. Don't put a lot of things on the bench. Right? Only put the necessary things. Otherwise, you may get trouble. Know the location of the power shutoff and the fire extinguisher. And do not have food and drinks in the lab or work area. That is, there are a lot of stickers on the notes. No food, no drinks in the labs. Okay, next one. This I think reviews engineering notation. What is engineering notation? 10 to the power of multiple 3, right? Exponent. What is the exponent? The power, okay? Matrix prefix. How many do we know? Right? You just mentioned several big ones. K, right? Meg, and gig, all this. Small ones. Micro, milli, pico, and the power of 10. Okay, scientific notation. If we want to convert a number into scientific notation, what should we be careful? Which part? What is the rule?
Make sure it's greater than or equal to 1.
It's greater or equal to 1. It can be 1, right?
Yeah.
But less than 10. Cannot be 10. Or cannot be 10. So greater or equal to 1 and less than 10. Then we have the proper power. Accuracy. What's this?
Sort of the range of error to the true value.
Right? It's very close.
Yeah.
It's the average, maybe you can see the average is closer to the correct data, right? What is the precision? Yes. And maybe it's, the error to its average is small, right?
Yeah.
So for example here, we said this is target, right? That is the correct data. And if your measurement like this, you can see the average of your measurement is very close to the correct data.
Right.
Although the range of error is large, so this is called accurate, but not precise. Precise like this here. Right? So you can see the average of your data is the error of your data is very small compared to the average of your data. And your average is here. But that average is not what we want. What we want is here. So this is precise but not accurate. Consistent, yes. Significant digit. We have a set of rules to determine the number of significant digits. Okay, now we have some quiz. That's where we should use the eye clicker. So we don't have it today, that's fine. A number written as this is said to be in which one? Scientific notation, engineering, both above and not above.
So scientific.
Scientific notation. Okay, good. Why? Because 2.59 is between that. The electric unit that is fundamental. Which one is fundamental?
Ampere.
So D, right?
D.
Okay. All others are derived from this fundamental. In scientific notation, the number this is written as which one?
B.
B. And what's the difference between A and B?
Negative power.
So this small number and 0.00056 change into a big number. The unit must be smaller, right? So the unit here is -4, not positive 4. Right? If the quantities increase is larger, then the unit must be small. So you can think of the 10 to the -4 as a unit, small unit. Right? Good, perfect. In engineering notation, the number this is written as
C.
D.
C, D. Which one?
D.
D, A.
One small space.
Huh?
Yeah, more.
We have a clicker, you can see. We have answers to each of all of this. Which one?
D.
D.
D. That multiple.
We have agreement?
Unit.
Huh?
Yes,
Both are correct? Which one is in C and D?
D.
Engineering notation, you cannot only have a multiple to 3. So here there's only one multiple 3, which is -6. Right? So D, right? The metric prefix nano is which one?
C.
C, -9, right? Pico, D, -12. This number, 2,700 megawatts, can be written as D, 2.7 gigawatt. Yes, everybody agree with this? Meg is 10 to the 6, gig is 10 to the 9. So that's the unit is 1,000 times larger. So the number must 1,000 times smaller. We move the dot to the left. That's 2.7 gigawatt. This one, 68 kilo ohm equal to B, 68 kilo ohm. What? Yeah, B.
68,000 ohms.
So B is good. How about A?
A is 2.
A is good too?
Oh no. All mathematics.
Right?
Yeah, they're all.
So all of them are correct, right? So A is also correct. And C is also correct.
Yeah.
So this one, you shift to the 3 times. So 1, 2, 3, so 68 kilo. This one is 68. This one is 68 kilo also. So all these are correct.
I didn't even see C. Or D.
The sum of this 330 m plus 1.5 equals what?
C.
C. So we have a C. Huh? D. We have D. Anyone see D?
There's this in way.
A. So we have A, C, D. Anyone see B?
This one's 1.5. Oh, it's 1.5. I didn't see that.
Yeah, 1.5.
It's D. I'm changing from C to D.
So which one?
D.
D.
15. Yeah.
Anyone has an objection? The answer is D. Yes?
Okay.
Yes, it is. Right? Give you a trick. In this case, it looks like we need to choose from this. Right? That is the instinct. Right? So So we change this m into w, so will be 0.33, right? And 1.5 plus 0.33, so that's 1.83. Precision. What is precision?
B.
Is this your job?
C, A, B, C, D. Which one? B. Okay, B. The consistency of a series of measurements. Yes?
Yeah.
Okay, good. Yes, that is correct. Alright, that's the answer. Right? You don't have any mistake, right?
No.
Okay. Okay, that's it for chapter 1. On the syllabus, you can see the required reading. Okay, is section 1.1 to 1.5. So basically, I think that is the whole book, right? The whole section, the whole chapter, right? Yes. So read the textbook and review the lecture notes and do the homework. I'll give you this. You can take a look. The website is here, and you go to the website, and you can see the class.
Dude, I said the first days.
11 EET101. Okay, another announcement. Everybody here need to be enrolled in EET101 lab. Yesterday, somebody, if you are in the lab, you need to be in this class. If you are in this class, you need to be in the lab. So this is a cool requisite. You need to enroll at the same time. If not, please go to Miss Sherry, and she can help to make correction.
Yes, thank you.
Okay.
Have a good day, sir. Yeah.